Welcome to this series of tutorials on using the Acrobat 3D Toolkit, which ships and installs with Adobe Acrobat 3D. You can use the Acrobat 3D Toolkit to add materials, create animations such as exploded views, edit lighting, and save these files as a 3D object or 2D raster vector image. This tutorial, the second in a series of 3, focuses on importing various CAD files and how to optimize the CAD files once they've been imported. Before loading a CAD file, right-click on the object in the list and check the Import options. In this case, I will right-click on a piston rod assembly. The surface tolerance and normal deviation properties control how coarse or finely tessellated the solid geometry is when importing and changing a tessellated polygonal-based mesh. The default value for most of the CAD importers is 0.5 for the surface tolerance and 30 for normal deviation. When I import the model with these default settings, an assembly is generated with 18,000 polygons in the entire scene. You can see this and other attributes in the information bar. The information bar displays the number of objects, lights, materials, vertices, and faces in the current scene. By selecting the object, you can see that this particular piston is made up of a series of polygons that form the three-dimensional mesh. When I zoom in on this object, you'll notice that this piston pin is coarsely tessellated. In other words, what should be a round circle is faceted. You can control how smooth or rough these meshes are by changing the import options. I'll right-click on the piston rod assembly and change the surface tolerance import options from 0.5 to 0.05. This will increase the number of polygons that make up this particular file. Now I'll double-click on the piston rod to reload the assembly. Then I'll press F12 on the active view to display a single viewport. Now, when I zoom in on this particular object, you'll notice that it is very smooth. You will also notice that it has increased from 18,000 to over 39,000 polygons. This effectively doubles the size of the file, which is undesirable. To optimize the entire assembly, I'll use the Reduce Model tool. With nothing selected in the viewport, I click the Reduce Model tool. In the dialog, I select Process to analyze all the meshes in the scene. Once this is completed, I can dynamically reduce the number of polygons by using either the slider at the top, by clicking any of the percentages, or by typing in the number of triangles or percentage of triangles I wish to keep in the scene. The slider dynamically displays the 3D mesh reduction in the viewport. If you zoom up on a part, you can view the polygon change as you change values. In this example, I can reduce the number of objects by 50%, or type in 18,000 polygons. When I first used the default settings of 0.5 and 30, I got a scene that contained about 18,000 polygons. By entering the 18,000 polygon number here, I reduced the number of objects by 54%. As you can see, the object that was once very tessellated and coarse is now very smooth, even though it is still made up of 18,000 polygons. As this example shows, the best practice is to import objects at a high resolution using the import options. Then, reduce the number of polygons using the Reduce Model tool. This procedure creates lightweight models that look smooth and are efficient inside the PDF. Now, I'll show you how to edit or create materials, and then save the materials so that they're available in any session within the Acrobat 3D Toolkit. First, I open one part in the viewport. Then, I select that object and press F12 to display it in a single viewport. I click on the Materials tab and change to Thumbnail View. I select a material, in this case metal blue, and drag and drop it on the viewport to apply that material to the selected object. There are a number of ways to edit the material. One way is to double-click the object. In the Object's Property dialog, select the Materials tab and double-click on Metal Blue. I can now edit that material. As an alternative, I can select the material by going to the Scene tree, expanding the Materials folder, and double-clicking on the Metal Blue material. By selecting the diffuse color, you can change the actual color of the material. In this case, I'll select one of the default basic orange colors. I also need to change the specular color to a neutral color so it doesn't reflect the light in blue. For this example, I select a neutral gray. As you can see in the viewport, the object is turned from metal blue to metal orange. In order to add the material to the available list, you need to perform a series of operations to isolate the material in the 3D scene. First, right-click on the Materials folder and remove all of the unused materials. Then, select the object and delete it from the scene. This leaves only the Explorer default material and the metal blue material, which I changed to orange. Now I can right-click the material and rename it from metal blue to metal orange. In order to save this file into the Materials folder for subsequent use by the Acrobat 3D Toolkit, go to File and click Save As. Then navigate from My Computer to Program Files, Adobe, Acrobat 7, Acrobat, 3D Toolkit, Materials. Supply the name, in this case Metal Orange, and select Save. The new material is now available inside the Materials tab within the Acrobat 3D Toolkit and can be used for any subsequent sessions.